When it comes to correlation analysis, we must first remember that the reliability of the y estimate that we just calculated now mainly depends on the strength of the relationship between x and y. So how we rely on that value that we just found in our previous question, that y estimate, mainly depend on the strength between these two, x and y. When it's stronger, obviously it's more reliable. And when it's weak or it's not so strong, then you also know that maybe I shouldn't rely on it. That's where now the correlation analysis comes into play. So by definition, correlation analysis is just an analysis that measures the strength of our linear association. So I'm just going to write here, it measures the strength of the linear association between two variables, or between x and y. I'm just going to write between x and y. So this is what we do, and the way we work that out, we have a formula. I'm sure this is not the first time that you've heard of it, that the Pearson's correlation coefficient. And this is the Pearson correlation coefficient, and it's this long formula here where the R is the sample coefficient relation, what we're looking for. X is the value of the independent variable, y is the value of the dependent variable, and n is the number of per point in the data sample. From just the question that we just solved now, let's see if we can work out a Pearson correlation coefficient. Actually, there's already a table that shows us this interpretation, which has been worked out, but we are just going to go through it and see what was done there. So from this table, you remember that previously we had the adds, we had the cells, and we had this one and this one. Now, because of this formula, they require us also to have a y square. We've just plotted the value, and same thing, you just make sure that you write all your total after you plot all the values here, and you bring it down and you substitute everything from this formula like it has been done here. Then you get a value like this. So when you get a value like this, the question now is how you need to interpret it. This correlation coefficient here, right, only you should only give us values that range between -1 less than r less than +1, obviously, and knowing that this is a strong negative and this one is a strong positive. Okay, and your value should always be somewhere around there, and that's how you can interpret it. There's a nice figure on the textbook where you see you have 0, means also that there is no correlation. So if you get a 0, there's no correlation, and like I said, strong positive or perfect correlation, and this one also you get perfect negative correlation. This is perfect positive correlation, but you should look at figure 12.10 from the textbook to see clearly what is being explained here. And we also have now um, graphical display of this interpretation, or the plots that will show this type of correlation. I think that's what we should look at next. This graphical representation is plot, or plots will also show us, like the first one here, as you can see, this is a representation of a perfect positive correlation when you have a +1 value, and this one is the extreme opposite, a perfect what, negative correlation. And this one is showing us some form of positive linear correlation, where you have anything from 0 less than r plus 1, with r being closer to the perfect positive correlation here. So it's more or less like that. And this one brings us to something from 0 to -1 as well, just on the opposite direction. And this one just shows you a positive linear correlation when your r is more or less closer to 0. And this one is also showing you now a negative correlation, but when r is closer to 0. And this one is just totally scattered, and this tells us that we have no correlation whatsoever there. So just make sure that you read that. But a Pearson correlation also does not imply a cause and effect relationship. It's just merely observed statistical association. And what also we need to remember is that a low correlation does not necessarily mean that those variables are unrelated. It just may mean that the relationship is poorly, or it cannot be described by a straight line. So those are the question that we must take from this type of analysis. Not every data might be mainly represented with those type of straight line. Now we are going to look at something that we call the R-square coefficient, or also known as the coefficient of determination. Coefficient of determination. Coefficient of determination. So I'm just going to clean up the screen here to explain and talk about what this is all about.